Hi everybody, it's Maths Tutor, and this is a integration by substitution example of how to deal with a square root. If you're familiar with the whole process that I'm going to use, then fine. If not, I'll go back to the introductory video and have a quick go through there. It introduces the concepts. In a square root, or in fact any root, I will call it, I think that's the important thing, we'll call it any root. So it could be a cubed root or any rooty thing, it doesn't really matter. This is the way to deal with it. Now from the other videos you'll see that if I have something that is basically nasty, I can turn it into something that is easy by finding some sort of u, substituting it in and making it u du, and that's what this process does here. And again, not going to go rapidly into that in any detail because you should have watched the previous video, but here we go. So we're going to look at this problem, which is x to the square root of 1 plus x squared dx, and the first thing I'm actually going to do is tidy this up, and I'm hoping that you're fairly familiar with the fact that the root of 1 plus x squared is the same as 1 plus x squared to the power of a half dx, and that's something you should know from power notation. And then what I'm going to do is going to look for the bit that is going to form the u. And again, it is explained in the previous video, but I'm going to hook out this 1 plus x squared because it sits in the brackets to a power. So u is going to be 1 plus x squared, and then I'm going to not dy, I'm going to du dx that, which becomes 2x, and then I'm going to take the inverse of that, which is, let's use another colour, dx du, which is 1 over 2x. Now this bit is this bit of my resultant, that what I'm going to achieve in the substitution, and I already know what fx is. I know what fx is, and that's this bit here. So all I need to do now is just literally put the whole thing together. So I'll keep colour coordinated for the right hand side for this bit here of my equation. So it becomes the integral of fx. Now fx is x. Now I already know that this becomes u. So I'm going to take that step and I'm going to say it's u to the power of a half, and then the next thing I want to add into my process is the dx du, which is the same as this one down here, and so that becomes 1 over 2x. And because I've been able to put in the function and the dx du, I can now say that the whole thing is du-able. Okay, so I'm going to go back to a single colour now. I'm just going to basically tidy this up. So basically the x cancels with the x, leaving me with a half, and I'm allowed to put that half out the front of the integral sign, and I'm left with this u to the half du. Now if I integrate that, or when I integrate that, I end up with, so that equals a half to the u to the 3 over 2, and it gets a little bit of a gets a little bit tedious, but there's a little bit of tidying comes up, and I end up with, which I'm not going to go massively through, I have to say here, people, because this is just, that's fractions and division of fractions, but this bit here ends up as being 1/3 u to the 3 over 2 plus the constant of integration. Now if I tidy, well, not tidy, but then reintroduce or reverse the u substitution, it becomes 1/3 1 plus x squared to the 3 over 2 plus c. That's it, folks, for square root. There are other videos which I'll be showing you some of the trig stuff, and also an exponential. I hope that's been of some help for you with a quick canter through. As I say, The basis of it all is the introductory video. Thank you very much.